so I had to explain all that. Okay, now the first few you can graph right on your note paper because I made grids for you. It's these ones down here at the bottom that you're gonna have to do on the graph paper. But let's start with the easy ones. These are reviewed. Tell me what x squared minus 3 looks like. You know this.
Parabola.
It's a parabola and it has been moved
3 to the right.
down 3. Kids, if you haven't yet learned the rules, you need to remember the difference between x squared minus 3 and x minus 3 squared. There's a difference. This is left and right, particularly this one right. This is up and down. This one down. Well, look, what's the next one then? That's a parabola, but this one has been moved to the right. I don't know what that number is on the end of the next one, so we'll just make something up. Let's just say it's minus 2. I don't know what it is, I can't read it. So is this another parabola? Yep. Where's this one moved? Left 1 and down 2. This is all review, guys. This is review. What about 2a? It is not a parabola. It is a V with a negative in front of it, so it is upside down. Now the next two are exponentials. So I'm going to draw my regular exponential up here. Again, your BFFs are never going away. You have to remember them. So this is the regular exponential. What does that do to that curve?
Flips it upside down.
Upside down. So instead of going up like that, it's going to go down like this. Does that make sense to you? And this point would be 0, -1. That picture upside down. So just pretend you can fold it right over. This is brand new. I don't think we talked about that.
Was it?
Opposite way.
Opposite way. So this negative is an upside down. This negative is a sideways flip. So this negative on the x, when you put the negative on the x, it's a sideways flip. So we went back to the original picture and we're flipping it sideways. So asymptote's still here, point's still here, but instead of going up like that, it's going to be coming down like this. Does that make sense to you if you flip this sideways? So a new thing to keep straight now. There's a lot to keep straight. Negative out in front, upside down. Negative on the x, so kind of inside the problem, sideways flip. Okay. What about this? What shape?
Parabola.
Parabola. What does that do?
Left 1.
Left 1. What does that do?
Flips it upside down.
Upside down. So left 1 and upside down. Did you keep that straight? again, we don't do a lot with the logarithm, so I'm gonna go ahead and sketch it like the regular one. So the regular logarithm, remember, has an asymptote here and goes through that point. So that is your regular logarithm. What does that negative, pay attention to where it is, what does that negative do? Sideways flip. So instead of being on the right-hand side, shooting out to the right, it's gonna be shooting out to the left. So it's still gonna have an asymptote right there. But now it's gonna look like this. Does that make sense to everybody?
What if you, never mind.
So a negative inside the problem, sideways flip. Now, how does that differ from letter F, which is also a logarithm problem, but now the negative is out in front? So go back, this is the original. What does a negative out in front do? Upside down, right? So in other words, instead of going up and out like this, would you agree it's gonna look something like this? So this part gets flipped up, and this part gets flipped down. Okay. All right, so now we're gonna use our graph paper. And we're going to graph some very strange, made up shapes. Not our BFFs, we just practiced with our BFFs. Now we're gonna sketch this. In our basic picture. Is this weird shape. Alright, so first thing we need to do, you can absolutely label them if you want. We are not doing it inverse, so we won't be doing any switching of the points, but you absolutely can label them if that's gonna make it easier for you. What you need to do is to remember what happens when the negative is out in front. When the negative's out in front,
Upside down.
it goes upside down. So see this little triangle right here? Instead of being underneath, it's now going to be up above. So this point doesn't change, that point doesn't change, but instead of coming down to, this one's gonna go up to. And then what about this little triangle right here? These 2 points aren't gonna change, but the V isn't gonna go up one, it's gonna come down one. And how about this triangle right here? It's gonna go down 2. And that little triangle is going to go up 1. And there it is. There's a picture of negative f of x. Because we know that this negative simply turns you upside down. Whatever you are, whether you're a logarithm or an exponential or this weird random thing, when you put the negative out in front, you tip it upside down. Now, how about the next one? What do you think's gonna happen with the next one?
We're gonna
Other direction.
make it real
It's going to go to sideways flip. Now, what does that mean in terms of the picture? That means if it was on the right, it's now gonna be on the left, and if it was on the left, it's now gonna be on the right. So when I look at my original, on the left is this little triangle thing right here. That's now gonna be on the right. So instead of being over -3, that point's gonna be over +3. Instead of being left 1, down 2, it's gonna be right 1, down 2. And there's that triangle now on the right side of the picture. See what I'm doing? Be careful and organized, it's not hard. Now, see this guy? Instead of going right 1 and up 1, I'm gonna have to go left 1 and up 1. There's that triangle. This one was right 3 up 2, so I'm gonna go left 3 up 2. Right 5 down 1. And there we go. So if it helps you to label the points, absolutely. Jacob?
If we get to a stopping point, maybe these questions.
Well, we're gonna do this all period. Do
Okay.
you really have to go?
Yeah.
All right, hurry up, leave your phone in there.
Thank you.
Okay, now I wanna skip a few, I wanna skip to G. Because what's happening in G?
everything's the opposite.
So we're doing both flips? We're doing both flips? This is where the colored pencils sometimes come in handy, because some of you are gonna be really, really good at this. I am not so good at it. I kinda have to go slow and methodical, so this is too much for me to do all at once. I cannot flip sideways and flip upside down all at once. So I'm gonna do one or the other first. So since I just got done wrapping this one, I'm gonna do my sideways flip first. So I'm just doing my sideways flip that I just did. I'm doing it again. And there it is. So I have taken care of this part of the problem, the sideways flip. Now, what do I need to do to that now? Turn it
Sideways.
upside down. So I'm gonna go ahead and just use my colored pencil, and I'm gonna flip all these things upside down. So this little triangle will come up. This one will come down. This one will come down. Now I got the advantage of being able to erase with my finger. It doesn't matter, you can leave those there if you want, just make sure you're using a different color. And this one goes up. So the blue is the final answer to the problem. If you can do that all at once, more power to you. It's okay if you split it up and do it in steps, because that's how I'll be doing it. Could I have done the upside down flip first and then switched it sideways? Yeah. either one. All right, are you keeping up with me here, guys? Are we good on what negatives do?
Yeah.
And where they are matters? Well, where the numbers are matters too, so let's look at C and D. What's the difference between problem C and problem D? Where the 2 is. And when the 2's outside like this, it means we're going up 2. When the 2's inside the parentheses, this one means we're going left 2. So these are 2 separate problems. All right, let's start with this one. Take everything up 2. So that means every point up 2. So this one, 1, 2, 3, this is negative 3, 0. Well, it's gonna go up 2, so won't it be negative 3, 2? What is this one gonna be if it goes up 2?
It's gonna go up to as well.
It's gonna be on the axis, isn't it? There's your triangle. And there's my picture lifted up 2. You need to ask if you have a question about that. All right, can you try this one? Can you move it left 2? Go back to the original now. Always go back to the original. And move everything left 2. So would you agree that that first point would be at negative 5 now? Everything left 2. Okay, tell me, do I need to wait on anybody here? Are we okay with this one, left 2? Did we get it moved left 2? Just point by point, move them over 2. All right, this next one is, for me, it's gonna be 2 steps. What's changing in this problem? What's happening? What does this negative do? Upside down. And what does this x minus 1 inside parentheses do?
Right.
Right. Okay, so I'm gonna start with that. I'm gonna take my original picture, always go back to the original, and I'm gonna move it right 1. So all these points are coming over right 1. you gotta help me out if you're stuck or I'm going too fast. Are we good on moving right one? Now, I'm gonna go ahead and use my colored pencil. What now is gonna happen to this picture? Because of this negative, it's gonna go upside down. So the triangle, instead of coming down, is gonna go up. The first one. And then the second one's gonna come down. The third one's gonna come down. And the last one's gonna go up. So there's my picture, and you do not have to erase, just use a color. Go over it heavy, dark, so I know what your final answer is. We moved it to the right, and we turned it upside down. All right, we have two more in this section, and I'm wondering if we have, like, if there's a pair of you that would like to come up and do each one. So you can do it by yourself if you want, but there's a lot going on in these problems, so it might be easier to have a partner. So F says F of negative x minus 3. And H, oh my gosh, H is a lot. Maybe I'll do H, since there's so much going on there. Anybody want to try F? Anybody want to try that one? Not yet? Okay, that's all right. Let's go through it. What does this do? I like to write down what's happening. What happens here? As a sideways flip. So however you say that. I say sideways flip. You can say left and right. What does that do? Down 3. So I'm going to do this flipping part first. So I'm going to take my picture, and everything on the left is going to the right, and everything on the right is going to the left. Once I get the sideways flip done, now I'm going to take all of those points and do what with them? Down 3. So on graph paper, that's easy. Just take each point and move it down 3. And the red will be the answer to the question. Sandra, you okay today? Everybody good? All right. Oh my goodness, we have 3 things happening. Tell me what's happening. What does this negative do? Upside down. And what does that do? Left 1. And down 3. Now in a lot of these problems, it really doesn't matter what order you do stuff, but I always follow the PEMDAS rules because then I know I'll always be right no matter what. So if I'm doing PEMDAS, the first move I'm gonna make is left 1, then I'm gonna go upside down, and then I'm gonna move it down 3. So that's the order that I'm gonna do things. So left 1, back to the original. every point is going left one. So left one. There it is, left one. Now I'm going to turn it upside down. Again, you do not need to erase. Certainly feel free to. You're kind of used to it with your piecewise functions, but you don't have to erase as long as you're using a different color. And now I gotta take it and move the whole shebang down. And the blue is the answer to the question. See how I did that a piece at a time? Everybody okay? Get ready, because we're going to talk about a new concept here. So let's make sure we know how to handle negatives, and we know how to handle adds and subtracts. Okay. Well, now we got a new shape that we're using for this next set of problems. The shape we are doing is a triangle. It's too wide and too tall. A semicircle, one tall and two wide. And a trapezoid that is one tall and three wide. We're not going to do all of these, guys. We're going to do a couple of them. All right, what's new and exciting about these problems? Now we have multipliers. We haven't had that before. We had adds and subtracts. Move it around. A multiplier is going to actually change the size of the graph. Whatever number is out in front multiplies the height of the picture. So in other words, since there's a 2 out in front of this thing, every shape is going to be twice as tall as it is originally. So how tall was this original triangle? It was 2 tall and 2 wide. Now the wide hasn't changed, only the height. So now he's going to be still 2 wide, but now he's all the way up to 4. A number, a multiplier, coefficient, out in front multiplies the height. So how tall was our semicircle? 1. Well, now he's going to be 2. number only affects height. My trapezoid came down 1, well now he's gonna come down 2, and there's your picture. We doubled the height of the figure. Okay? Now, tell me about this. What's gonna happen here?
You're gonna have.
It's gonna be half as tall,
Half as tall.
and it's going to be upside down.
Upside down, yeah.
So let's see if I can do all that at once. It's gonna be half as tall and upside down. So, see this triangle? He went up 2. Well, now he's gonna go down 1. He's upside down and he's half as tall. My semicircle went up 1. Now he's gonna go down a half. Lynn?
Yeah.
You okay? And then what about my trapezoid?
He goes half as well.
He's gonna go up, but half. There you go. Okay. All right. This one has a half in it too. What do you notice about that half though?
It's inside.
It's inside.
So is it gonna change the
And it's gonna change the width, but it's gonna change it opposite of how you think. This number actually divides the width. And when you divide by a half, aren't you actually timesing by 2? Think about it. When you did 5 divided by a half, didn't you change that into 5 times 2 over 1? So what's gonna happen to that picture?
It's gonna double in width.
It's gonna double in width. So every figure, you may have to extend your graph, do the best you can. It's gonna be wide. This triangle was originally 2 across, now it's gonna be 4. The peak is halfway in the middle, right? So if it's 4 across, the peak is now at 2. That semicircle was also 2 across. Now it's gonna be 4. And it's still the same height, so it's 1 tall. And what about that trapezoid?
It's gonna be 4.
6.
It's now gonna be 6 across. So I gotta march over 2 to put my first dot, another 2, and another 2. There it is. All right, we're gonna do one more, and I'll stop for today. We're gonna do letter E. Letter E. So tell me what's happening in this problem. Well, two things. What's that that negative do, pay attention to where it is. That negative is a sideways. And what does a coefficient inside the parentheses do? Divide, divide, divide. So this is gonna divide the width. So isn't this one gonna be half as big as it was?
Yeah.
Divide by 2, it'll be half as big. So we're gonna sideways flip it and make it half as y. So see this triangle right here?
Yeah.
He's on the left and he's 2y. Now he's going to the right and he's only gonna be 1y. Notice I didn't change his height. A number out in front does that, right? All right, here's my semicircle. He's on the right, and he's 2y,
Mm-hmm.
so he's going to the left, and he's 1y.
Yeah.
And then my trapezoid is also coming over here. He's originally 3y. Ooh, odd number, doesn't matter. Now he's gonna be 1.5. 1.5y. And he's still 1. There it is. Okay. Tomorrow we have one more transformation to talk about, and that's the absolute values. So that'll have to wait till tomorrow.
Yes, sir.